Okay, you've opened up a new workbook and entered your phone number as I've shown it here, downward in column B. I've also added these labels because we're going to think of these numbers as scores. Maybe they're scores on an achievement test, let's say. We're interested in sampling every possible sample of size 2 from this population here of 7 scores. Now, in the real world, we obviously wouldn't be doing this with only 7 scores. We just use the mean that we could calculate simply by going to cell B9 over here to auto sum and choosing the average option. And we find out that our population mean is 3.71. But we want to simulate what would happen if we drew samples of size 2 from this population. So I'm going to start by copying all of these scores into cell E2 through E8. And I'm going to do this now all the way down to cell E50. And I'll tell you why in a minute. There are 49 possible samples of size 2 from a population of size 7. How do I know that? Well, in order to find out the number of possible samples from any population with a given size, take the population size, in this case it's 7, and raise it to the power of the sample size. In this case, the sample size is 2. So we're going to have 7 squared, 7 to the second power, which is 49. So because I'm starting in E2, I'm going to go all the way down to E49. All right. Now I'm going to go over here to cell D, following the instructions, and I'm going to enter a bunch of 8s here all the way down to cell D8. And now I'm going to take my second number, my second score, which is a 0, and I'm going to do the same thing. 1, 2, 3, 4, 5, 6, 7, 8. Oops, no, 7, like that. What am I doing here? Well, in this instance, let's take this one over here as a first example. I'm drawing a sample of size 2. So I went to my population and I drew a sample, and I happened to get case number 1, who scored an 8. I put him back in. I sampled again. This time I got case number 3, who scored a 6. So I have my first sample, my first case, and my second case from my sample. In this instance over here, again, I happened to draw case number 1, but I put him back, and the second draw was case number 4. Over here, I'm sampling with replacement. Don't forget that. I'm sampling with replacement. So I drew this guy over here, got an 8, and I put him back in, and then purely by chance, I drew him again. That could happen. So I'm going to fill this down as per the instructions, and I'm going to pause the video so you don't have to watch me cutting and pasting here, and we'll resume in a minute. Okay, now I have every possible sample of size 2 in column D and E, rows 2 through 50. All right, so now let's find out what the average of my samples are. The average of these two samples are going to be equal to the value in D2. Oops, I need a parentheses. D2 plus E2 divided by 2. That's how you that's how you compute an average. So that average is 8. The average of 8 and 0 is going to be 4. And I can fill down the whole way and get all the averages of all the possible samples. The central limit theorem tells us that the mean of a population should be exactly equal to the mean of all the possible samples that I might draw from that population. In column F, I have all the possible samples. I have the mean of all the possible samples that I might draw. So we know our population mean is 3.714286. What's the mean of all of these samples that we drew? Well, again, we'll go down to row F51, select auto sum, the average option, and the mean of all of the possible samples from this population of 7 is 3.714286. And that matches exactly our mean over here. If for some reason the mean that you calculated for your population doesn't equal the mean of all the samples that you drew from your population, you made a mistake someplace. Most likely the mistake is going to be in column D or column E, so you want to go back and check those. All right. Now I'm going to go into figure out the frequency of each of these samples. And I'm going to do that by first creating my bin range. Okay, and of course in this case it's not possible to get a sample average of 9 because there are no values of 9 here, but in your number there may be a 9, so I'm going to include it here. All right, how do we do the frequencies? Again, we select the first cell there, drag down one below that one, go up to the formula bar and type in the frequency command, and it starts it out for us. And first we need the data array. The data array here is we're looking for the frequencies of these different averages. So we're going to go from F2 all the way down to F50. And that's our data array. And our bin range is this over here. So I close the parentheses. Before I do anything, I'm going to hold down the Shift and the Control key, press Enter, and these are the frequencies. So you can see something kind of interesting here. We know that the true mean of the population is 3.71. It looks as if most of our means are pretty close to that. Let's figure out in percentage terms or probability terms. Let's not look at this first. Let's follow the instructions here and look at the outlying scores. So we have 49 total samples. So the denominator for our 4 outliers is going to be 49. So I'm going to say equals, and I'm going to take this plus this plus this guy plus this guy. Probably doesn't make any difference. You could have also done it these two. Okay, because I don't know whether or not it makes sense to consider 9 a possible score since it isn't really possible to get an average of 9. And as usual, I forgot to close the create parentheses here. And we're going to divide by 49. So what's this number going to give us? This is going to give us the percentage of sample averages that are either 0, 1, 7, or 9. There are, again, a total of 49 cases. That's why we're dividing by 49 down here. Click Enter. Only 18% of our possible averages are these outlying scores. How about the extreme values? Do almost the same thing, but this time we'll just look at these ones way out here. Again, I forgot to add the parentheses. We'll take that one plus this one over here, because again 9 is impossible. And again we're going to divide by the total number of possible samples, which are 49. Only about a 10% chance of selecting an extreme outlier. So what is this telling us? Well, it's telling us that yeah, we might select a sample that has a really weird mean. That is possible. But it's so much more likely that we're going to select a sample that is not that, where the mean is much more representative of the true population mean. I don't ask you to do this in the handout, but let's just do it for fun here. Close to mean, I'll type. And then we'll select these cells over here that are close to the mean that we calculated. And we will then divide by 49. Fully half the possible samples that I could draw, fully half the samples are very good estimates of the mean. All right. Well, the handout asks you to do this on 3 different sheets with 3 different numbers. You can use a friend's number, a family member's number. You can make up a number if you like. Just bear in mind that you shouldn't select the 7-digit number that has too many repeating numbers in it, too many repeating digits in it. If you want, you can make up a random number. Just, again, follow the guidelines on the first page of the handout to make sure that the number you pick will be a good number for this problem. All right, we'll leave it at that. You've got some questions to answer, and I'm looking forward to seeing your answers.